In this video, I'm going to continue looking at writing the equations of trig functions. So I have a graph here you can see on the screen. And just like before, I always am trying to find the amplitude, midline, phase shift, and period, and then trying to kind of adjust from there. So this one, it's pretty easy, I think, to see that the amplitude is 2. Should be pretty straightforward there. You can see 2 units of height there, so that should not be too difficult to deal with. Amplitude is going to be 2. If you see the midline here is going to be at y equals 0, so basically we don't need to do anything to change the midline. That hasn't been shifted up or anything like that. The phase shift, okay, you do have to decide if you're going to work with a sine or a cosine function. And there's not a right or wrong answer here, but I do think there are cases that are a little bit more obvious. Because the sine function normally starts out at the origin, and it basically does this sort of thing. Typically, if the graph crosses the midline in a place that I can tell, I'll usually use that. So I would look at this point right here and I would be thinking, okay, it's probably crossing there. So I can set this up like a sine function and do it that way. Now, you could look at this higher point here. The cosine function starts out at a maximum. If you want to say this is a cosine function that was shifted 2 pi over 6 units to the right, you would be correct. So that is actually an option. Anyway, I'm going to go with the sine, though, because I can see where it crosses the midline. And when I can see that, I normally do sine functions. So the phase shift here is going to be pi over 6, okay, or 30 degrees if we were using that. Now, the period of this function, okay, we're going to have to be a little bit careful with the period here. Notice the period is going from pi over 6 to 5 pi over 6. Okay, that's 1/6 to 5/6. Okay, so 5/6 minus 1/6 is equal to 4/6. 4/6 is actually 2/3. Okay, so the period is actually going to be 2/3 pi radians when we put this whole thing together. And as a result, that's what I'm going to be using here for the period, 2/3 pi radians. And so anyway, or you could write that as 2 pi over 3. Okay, be careful here. If you remember in the equation here, this b value is the value that determines what the period is. It's not the period, though. I'm not going to drop a 2 pi over 3 in that position there. Okay, so remember the key here is that the period of your function is 2 pi divided by that b value. Okay, so you need to look at 2 pi over 3, and you need to figure out what did 2 pi get divided by to be 2 pi over 3. Okay, and I think you can see in this case, 2 pi got divided by 3. That means my b value here is going to be 3. Okay, and that just means that this is a sine function that's moving 3 times as fast as the regular sine function. So anyway, if we put this together, we've got y equals, it's going to be 2 sine. We're going to have that multiplier of 3 because that b value there is 3 if you look at the form. And it's shifted pi over 6 units to the right. So we're going to have an x minus pi over 6, okay? And it hasn't been shifted up at all. So we don't need to do any kind of horizontal shift. We don't need to change the midline. That should be the final version of the equation. Again, if you're looking at this and thinking, well, couldn't I have done a cosine function? Yeah, you could do a cosine function. The only thing that would be different is the cosine starts out at the maximum. So your shift would be that 2 pi over 6 to the right instead. The amplitude and the b value affecting the period and all of those other things will stay exactly the same. So I hope that makes it a little bit more clear how you can write the equations of trig functions based on the graph.